Okay, good afternoon. I'm here to entertain you for half an hour about this topic of manufacturing tool, hoping to not disturb any of your digestion process. This presentation practically is one step in the direction that Mark was indicating this morning about a number of different pieces that need to come together in order to allow for our UEFI-based system to be deployed and to be successfully used. So I will go through this agenda today. I'm first talking a little bit about what are typical scenarios about manufacturing tools existing until yesterday, and what is the impact that UEFI is bringing to this subject, and how we can address it. All OEMs in this room and that produce platforms obviously cook inside their platform some secret sauce that typically need to be deployed, that need to be provisioned in a manufacturing environment. Often it is necessary to have a specific handling of each and every platform that is, each and every sample that is moving to the manufacturing line, in order to configure parameters that are specific to the that identify the specific machine. So what are examples of these tools that are typically used in manufacturing? Tools for installing, pre-installing an operating system so that we can deliver a machine that is already ready to use out of the box. Tools that allow to install special activation keys directly into the system so that the installed operating system, again, can be immediately used out of the box. Configuring of parameters of specific hardware devices like MAC address for network controllers, information that need to be stored into SMBIOS table, for example, in order to provide management capability for the platform. Updating the BIOS and all other firmware that are typically present on the board that is in production to the latest version, provisioning all the necessary security keys that are required in order to have a secure boot feature for UEFI working properly. It is a reality that today there are plenty of tools that has been created by OEM in order to perform this configuration on the manufacturing lines. And it is also a reality that many ODM have a very elaborated manufacturing environment where all these tools provision the various platforms on the line. Now, until yesterday, the majority of these tools has been developed as legacy tools, and as such, they cannot be used in UEFI environment with Secure Boot enabled. With Secure Boot, we make sure that every piece of software that is executing into the pre-boot space and the OS loader is fully identified, and so that the handoff from the firmware to the operating system is fully controlled. So only authenticated images that has been signed by certificate authority can be executed on the platform. In order to have a secure boot environment, we need to have also a certificate authority that certifies where these piece of software are coming from. And currently, we have only one certificate authority, UEFI certificate authority, that is run by Microsoft. And the certificate authority has certain rules and regulation in place in order to decide if a certain piece of software can or cannot be signed, and every time that a new driver, a new bootloader, a new application, UEFI application is submitted, the certificate authority verify that all these conditions are respected. And obviously there are two possible outcomes. One, if all the conditions are respected, the piece of software gets signed so that it can be validated prior to be executed once that is used, one that is invoked by the firmware. Or the other possibility is that if all the signing requirements are not fulfilled, the driver, the application can be rejected and requested to be modified in order to be approved. Now, throughout all this presentation, you will see that there are many links. All these slides will be available on the UEFI website, and all these links will be active. As we were saying, if we have manufacturing tools that are only legacy-based, there will be surely issues, and in some situations they can be worked around, but in case of UEFI class 3 system, that would probably be a complete roadblock. Now, for who is not familiar with the classification of the system, UEFI, we identify systems through class 0, 1, 2, and 3, where class 0 are the traditional legacy system, completely legacy. Class 1 is legacy system with an UEFI layer on top of it. In class 2 we have are UEFI system that still support the ability to boot the system also in legacy mode. Class 3 are pure UEFI system where the legacy support module is not existing at all. So there is the complete impossibility to execute legacy application. So as we see, there is absolutely a need for manufacturing tool to be changed in order to support the provision of this new class of devices. What we can do in order to move these provisioning tools to UEFI. UEFI is a very powerful and feature-rich development environment that allow to develop any sort of driver or applications that can facilitate the same operation that were executed in legacy mode. Also, it is possible to have easy access to the network. I think that later in the week we will have a presentation about using, for example, libcurl as an easy way to develop UEFI application with network access. So UEFI is fully network enabled, and developing applications that have the possibility to interact with the network is surely that is possible. UEFI also provide all the methods, all the systems that can be used in order to configure any piece of hardware, any hardware device that is present in the platform. And so it can be, protocols can be used in order to configure attributes, to develop application, to provision operating system. So this is an example of a system that needs to be provisioned, that you can approach the system with a USB key or provision the device through the provisioning network. As we indicated before, there are strict rules that allow that are defined by Microsoft to how to sign driver and application, and the current rule do not allow to sign manufacturing tools. As a matter of fact, it is clearly specified that shell manufacturing tools, debug tools, and any application of the sort cannot be signed. And there are good reasons for this, because really manufacturing tools operate, execute to what it is equivalent to a ring zero execution environment, where practically your application has full access to any hardware device, any hardware function present into the platform. Good reason for not signing with the UEFI key is that once that tool of this type could be signed with this key, they could be executed in any platform, and typically manufacturing tools have a very close interaction with the firmware and the platform itself on which they need to be used. So allowing manufacturing tools to be executed on any type of platform would probably not be a good choice. So what are the possible solutions for this problem? One very common solution is to sign the utility with a OEM specific key. So using the same PKI mechanism that is used also with Secure Boot, but using a different set of keys that are OEM or platform specific, and embedding the public key that has been used to sign the specific tool into the UEFI authenticated variable. This embedded can be a temporary embedding, can be an embedding that is done together with the other keys that are required for Secure Boot. Various are the possibilities that can be adopted in order to incorporate the public key that enable the manufacturing tool to be executed into the UEFI environment. Once that the public key is enrolled into the set of UEFI authenticated variable for Secure Boot, at that point the application will be allowed to be executed exactly as a bootloader signed with the UEFI certificate authority can be executed. Now, the process of signing the manufacturing application can be done both in Windows, in Linux, or any other environment supporting signing processes. In Windows, you can use sign tools. That is a tool that Microsoft provides to us as part of WDK. In Linux, we have other signing tools that are based on OpenSSL. The real problem, though, I want to underline here, is not in the technicality on how to sign the specific application, but on how you really manage the keys that you could use to sign your tools, because clearly the ownership and the processes used to manage these keys are a fundamental element that is at the base of the security of your manufacturing environment. So it is very important the way in which the private keys used to sign the tools are managed inside the organization. There are every sort of recommendation that best practices that the security community is recommending. There are hardware devices that are specifically used in order to store in a secure way keys, hardware security module, and other solutions. This is the main recommendation: to sign your manufacturing tools and control the way in which your manufacturing tools are used in manufacturing. There are also other possibilities, like, for example, we were saying before that there are OEMs that have developed specific operating system-based solution in order to provision a platform based on a Linux kernel or other based on Windows PE. So in this case, obviously using Windows PE or using a signed Linux kernel, you still have the possibility to continue to use your operating system based manufacturing tools also in a secure boot environment. Other solutions are obviously related to not enabling secure boot in manufacturing, keeping your platform with secure boot disabled in manufacturing, but ensuring that you enable it before the unit leave the manufacturing line. Also in this case there are really two cases, because as we were indicating before, if you use legacy tools you cannot use them on class 3 system, but if you have unsigned UEFI tools, you can use them on any system, class 3 included. I have now a small demonstration of how it is possible to execute application, signed application into a secure boot in the secure boot environment. Instead of bringing here the board, I have a short movie that I can show you if you want to see and exercise with the real application. In our room 434, I have all the tools with me so that I can show you a live demo. Okay, here we are in the BIOS environment, and we show that the secure boot is enabled. The item on top, secure boot enabled. And we go to try to execute the UEFI application unsigned. So my application unsigned, and the execution says access denied. So now we sign, we run the sign tool to sign the application. We go to enroll the key into the DB. And now that the key is enrolled, at this point the signed application will be able to execute properly. This is the process with AMI BIOS to add a certificate into the DB, selecting a certificate from a file system. So from the root file, from the folder sign demo, the public key corresponding to the key used for signed, mycert.cer, is loaded as a public key certificate into the DB. At this point, the system is provisioned with the ability to run application signed with that specific key. So the unsigned application will still be rejected, while the signed application at this point will be allowed to be executed, because at this point the system has knowledge of the public key corresponding to the private key used to sign this. The call to action for all of you is to consider the transition of any left legacy tool into your processes to be converted to UEFI, because the conversion to UEFI is absolutely a need at this point, because class 3 systems are growing, and the shipment of class 3 systems are surely on the rise. There are, as described before, there are several different possibilities in order to enhance and upgrade the manufacturing environment and the provisioning used in manufacturing. Every OEM should consider which is the best solution for their own purposes. And the final call to action for everybody is to become more familiar with processes on how to sign driver and applications, and how to interact with the system in order to append, to insert the keys that are necessary for your processes into your systems.